Great.
Hello, in this section, I will do a few more problems involving logarithmic functions, chain rule, that involves logarithmic functions and chain rule and power rule. Okay. So yeah, we're going to do more derivatives involving logarithmics. So if you haven't seen my video on logarithmic differentiation, go ahead and check that out. Yeah, before you do these problems, because it'll make it easier. But let's just review some common log derivative rules. So if the derivative of log base b of x is equal to 1 over x times ln times b, and then the derivative of ln of x, so it would be 1 over x times the derivative of x prime. So it's like the chain rule. Okay, so yeah, so let's do some examples. So for the following problems, find the derivatives. So let's start with example 1. We have y equals ln parentheses x cubed plus 1, and we want to find the first derivative. So that would be, we're going to use rule number 2. Or you could think of it as the chain rule. So it would be y prime equals 1 over this log, this thing, and then times it by the derivative of this thing inside the parentheses. So the derivative of x cubed plus 1 is going to be 3x squared because I use power rule. And then the derivative of 1 is just 0. And then over this thing, you just leave it alone. You don't take the derivative. And that is your final answer. Okay. Example 2, find the derivative of ln of sine x. So it's going to be, yeah, I think we're going to do rule number 2. So you could say y prime equals 1 over this thing, 1 over sine of x, times the derivative of inside the parentheses, so the derivative of sine of x. So that would be the derivative of sine of x is positive cosine of x, and it's just in the denominator, it's just this. Example 3. What are we going to do here? In order to take the first derivative, maybe it would be easier if I wrote it as a power, as an exponent. So we all know anything right in the square root can be expressed as ln of x parentheses to the 1/2, right? So how are we going to take the derivative of this? So we're going to use two things. We're going to use the power rule and rule number 2. So f prime would be the power rule, so it would be 1/2 parentheses ln of x, and then you subtract 1 from the power. So what's 1/2 minus 1? Or 2 over 2, because 2 over 2 is the same thing as 1. 1 minus 2 is negative 1 over 2. So negative 1/2. Okay, and then what you're going to do is take the derivative of ln of x. So that would be so it would be times the derivative of ln of x. So we know the derivative of ln x is going to be 1 over x times the derivative of x, which is really just 1. Okay, let's clean this up. So this is going to be 1 over 2. And then this is going to raised to the -1/2 would be expressed as it's equivalent to saying 1 over ln of x to the 1/2, right? And then anything raised to the 1/2 is like a square root. So this would be 1 over square root of ln of x. So it would be square root and then ln of x. Okay, and then times it by 1 over x, and then the derivative of x prime is just 1. So it's going to be f prime of x equals to 1 over 2x square root of ln of x. And that would be a final answer. Move on to example 4. So on example 4, we're actually going to use rule number 1. So the rule number 1 is like d over dx, because we have a base. Well, actually, yeah, it's going to be the rule number 1 was log base b of x equals to 1 over x times ln b. So, okay. F prime of x is going to be 1 over x. Our x is this whole thing inside the parentheses. Times ln of b. So what would be our b, our base? Well, as you can see, we don't have a base. If you don't have a number, it's automatically an indivisible 10. So our base is actually going to be 10. Okay. And then times it by the derivative of the inside. Okay, so that would be f prime of x equals to, so let's take the derivative of this. So derivative of 2 is 0. The derivative of sine of x is positive cosine of x. And then this stays the same. And then you could just leave ln of 10 alone. Just leave it like that. That'd be fine. So that would be your final answer. Okay, example 5. What are we going to do to take the derivative of this thing? So we're going to use log. Bless me. We're going to do logarithmic differentiation. So we're going to use logarithmic differentiation. And then so one of the first rule of using logarithmic differentiation is we're going to have to expand using log properties. Okay, so you could say that ln of x plus 1 over square root of x minus 2 is equal to ln. Okay, so we are dividing. So when you're expanding, when you're dividing, you're really subtracting. So this could be expressed as ln of x plus 1 minus ln of square root of x minus 2. Okay, and then the square root of x minus 2, we can rewrite that as a power. So that can be expressed as, well, this stays the same. And then square root of x minus 2 can be expressed as parentheses x minus 2 raised to the 1/2, right? And then when you have a power, when you're expanding it, you put the power in front of the log or the natural log. So it would actually be minus 1/2 ln of x minus 2, right? And then from here, we could just take the derivative. So let's start with this one, this term here. How do we take the derivative of this? So it's going to be 1 over x plus 1 times the derivative of the inside parentheses. Minus 1/2, and then the derivative, okay, so 1/2 it's a constant, so we could just ignore that for right now. So the derivative of ln parentheses x minus 2 would be 1 over x minus 2 times the derivative of the inside parentheses. Okay. So let's clean this up. So on this one right here, x derivative of x plus 1 is just going to be 1. And then this stays the same. Minus 1/2, and then times 1 over x minus 2 times the derivative of x minus 2 is just 1. So when you actually do clean this up, this is going to be 1 over x plus 1 minus 1 over 2 parentheses x minus 2. I'm not going to FOIL out this 2 because I am subtracting a fraction. So when you're subtracting a fraction, you need a common denominator. So what would be my common denominator? My common denominator would be 2, x plus 1, and x minus 2. So on this side right here, what are we missing? We are missing an x plus 1. Multiply top and bottom by x plus 1. Over here, what are we missing? We're missing a 2 and a x minus 2. Okay, so when you actually clean this up, this is going to be 2x minus 4 minus bracket, and then this is just x plus 1 all over the common denominator, which is 2x plus 1, x minus 2. So FOIL out that minus, so that's 2x minus 4 minus x minus 1 all over 2 times x plus 1, x minus 2. And then when you collect like terms, it's going to be x minus 5 over 2 times x plus 1, x minus 2. And this would be your final answer. Oh, and I think that is the last problem for today. So, yep, that's it for today. Okay, thank you. Bye-bye.